And then let us move on to the next speaker. The next talk is going to be by Kolja Bailly, and the topic is From Triples to Text, LLM-based approach to querying Wikibase content. So please, Kolja, the floor is yours.
Thank you very much. I will share my screen. There we are. Okay, hi. My name is Kolja Bailly. I'm a developer at the Open Science Lab in TIB Hannover, and my presentation is about retrieval-augmented generation systems in Wikibase for research. So in my presentation, I think we have two main questions. First, what is RAG? And second, what is Wikibase for research? I will start with the Wikibase for research topic. So Wikibase for research is mainly an installation pipeline for Wikibase or any other MediaWiki configuration that we build in the Open Science Lab, because there is a already good Wikibase Docker pipeline to install it. But for many of our research projects, we need custom configurations. So for example, other installation of extensions or combination with semantic MediaWiki and so on. And to automate this process, we built Wikibase for research. So you can think of it like this. Normally, we have the MediaWiki framework, for example, with Wikibase as an extension. And okay, most people here might know this, but just to make it clear, so this talk is not necessarily RAG in combination with Wikidata, which is a collaborative platform built on top of Wikibase. So Wikibase as a software. Here I speak about projects that are using MediaWiki and Wikibase software for their own data. So holding their own local database or collaborative database for single projects. Wikibase for research is then just a software tool that we use to keep out all the IT and software administration out of the research projects. The configuration of this tool is then part of the projects, together with all the content and images that are part of the research. And in Wikibase for research, it's just a configuration which extensions shall be installed and automatically load in all the data. And some of the extensions are public and others are developed by ourselves, which, for example, Antelope is a tool for data annotation, and also the RAG system that I present today. Okay, for the second question, what is retrieval-augmented generation? So in general, this topic is about data retrieval from data sources. And if we are using large language models, we have often the problem that these models are not trained on very special data. So for general topic, the answers might be good or okay, but the more we go into detail or into special knowledge domains, then the large language models lack of good answers. And RAG is an approach to solve one of these problems, and it works like that. You have a user that is giving a question, and instead of giving this question directly to the large language model, we use a component in the middle called the retriever. And this retriever is using a context database. For example, our own database of our research project, to pull out relevant information, which might be relevant to answer the question. And then we provide the question together with the context data to the large language model just to generate an answer out of it. So the LLM has not to rely on the data it is trained on. It can use external data then. The pros of this approach is that we have a lower risk of hallucination in LLMs. And also we have support of this specific knowledge. And when we have such a system, there are two types of information that we might have. First is we might have unstructured documents like text files, text data, articles, papers like this, or we might have structured data like knowledge graphs, relational databases maybe. So every context where we have structure in our data. We need to handle both of these, or our retriever need to handle both of these. And also we need some methods to transfer unstructured documents into structured data, like for example, a knowledge graph retrieval out of a corpus. And to give you one example how RAG works under the hood, so we begin with the indexing. Let's assume we have unstructured documents in our database, for example, Wikipedia articles. Then in the indexing, we would take every document and split it into smaller chunks. So for that, we need a chunk strategy. So for example, we could say one sentence in the document is a chunk, or one paragraph, or maybe a fixed block of 100 chars. So the chunk strategy defines a bit on which level we want to access information later on. If we put whole documents in, then we can answer questions about the content of the whole document. If we have smaller chunks, we can access later very specific information. And then we use an embedding model. Embedding models are trained models, mainly statistical models, I would say, that are trained on large corpora, for example, text corpora, and that assign a text or an image into a vector space. So assume that you have a vector space. So these are multi-dimensional vector space, but just imagine it as a three-dimensional space. And these models try to locate each word in that space so that words that are semantically near to each other are neighbors in this space. So for example, France and Germany might be quite near to each other because they are both countries. France and Berlin might be a bit far away from another because Berlin is not in France and it is not a country. And after that, all our information in our database are located in the vector space. Now the retrieval, when a user comes to the system, the user enters a question in a natural language, and then we use the embedding model. This is one strategy to translate the question into the same vector space. So for example, the user writes which person of interest lived in the 17th century, and we transfer the sentence into the vector space and look which entities in our database are lying around, which are the neighbors in this vector space. And the hope then is that these entries in our database are most relevant to answer the question of the user. And then last, in the generation phase, we use the question of the user together with the relevant chunks we found and provide this to a large language model to with the task to generate an answer using only information from the chunks to answer the question of the user. And thus we have a system that can answer natural language questions with natural language, but using specific data from our database. Our system need to handle structured and unstructured data depending on what system we are using. In a plain MediaWiki like Wikipedia, you have articles which are mostly unstructured data. If you have a pure Wikibase, you have items and properties like a graph, which is structured data, but there are also mixed configurations. So for example, if you use semantic MediaWiki together with Wikibase, you might have both. And to handle this, we are using the LlamaIndex framework, which is a public framework. It's open source, and we rely on an early prototype of a colleague of mine at TIB, Alexander Gesin, who wrote this for an implementation to handle MediaWiki articles, and we extended it now also to handle structured data. As a software, the architecture is the following. You have Wikibase for Research here, and Wikibase for Research starts Docker containers for several services. For example, Wikibase is then a Docker container that is started. And now the rec system is another Docker container which can be run. That means you can also use it without Wikibase for Research. You can just start the Docker container. And in that container, you have several components. One, for example, Flask opens up an API to communicate with the system. You have a Elasticsearch database. You have some systems for using and handling embedding models. And then you can communicate to that component via API. For example, you can write a web form and embed it in your Wikibase or in your MediaWiki to give access to that component. But you could also write a complete external web form and communicate via API to that. So that makes it a good variable tool. And as a first use case or case study, we used one of our research projects. It's called Manor Houses of the Baltic Sea Region. So it's about manor houses. We have a few thousand entries of manor houses, and a few dozen of them are enriched with also articles. So we have a wiki base with a lot of information about all the buildings, about owners, about the state of the buildings. And also we have a lot of unstructured texts written by the researchers about all these houses. And here you see, for example, the combination that we use semantic MediaWiki to display the information out of also out of Wikibase in a nice way. And we use this data to index all this via the rec system. And then we tried how good the system performed. And here I have 3 examples. For example, if you insert the question, who owns the manor house Christinehof, the system can answer it correctly. Interesting here is, for example, that it states in the structured information here, you have owners on the web pages line by line. And the answer is here that one of the manor houses is held by the Piper family. So here you see one of the pros of large language models, which can detect that if 4 owners ends with Piper, I can say, okay, it's owned by the Piper family. Also, if we have some dates, so we want to retrieve some dates which are exactly written in a sentence or in structured data, this works very well. And in the end, I have a good example of tasks that cannot be well performed. So if, for example, we used here a question which was a bit around the back maybe. So which manor house was built by the widow of a man who played a significant role in the Swedish state apparatus? There was an article that was written exactly using part of this sentence. So there was such an example. And the rec system was not able to retrieve this example. But on the other hand, it retrieved another example which was not totally wrong. So for example, the LLM decided here that another chunk was relevant where the husband of a woman became brother-in-law to a person who played a significant role. So the rec system was able to detect that there was kind of an indirect connection to the Swedish state apparatus. So this is a good example of what is possible. And you see here that the hard thing is to get the relevant chunks for the question. Current state of the system is that we have components as well for handling wiki pages, also for handling the Wikibase information. Currently, this is functional but not optimal because we are using an in-memory database to make a duplicate of the Wikibase data. So this is not optimal, but for indexing, it's okay. And I want to also to give you some information about what are the strategies. So what are the, if I want to optimize this system for my own data, what I have to think about. So for example, the indexing strategies. If you get a query, which is a user question, you have to think about, okay, how do I identify the relevant chunks, the relevant nodes in my database? For example, you could say, I translate the user question to the vector space and get the nearest neighbors. And then I provide these to generate the answer. But you could also say, I use the query and I have a controlled vocabulary and try to identify these keywords in the user question, for example, climate or New York City. And then I do a keyword search in my data to identify the relevant nodes and provide it to the LLM. Maybe your data is a hierarchical data. Then you could say, I try to use the user question to identify one root node and provide all the root node together with its children's as information to answer the question. Or if you're using a property graph, you might identify more than one nodes and use their neighbor nodes. And the good thing is here that LlamaIndex provides us already with good implementations about these things. And I will give you examples of that. So for example, there's a class synonym retriever which says you get the user question and you use a large language model to create synonyms out of this user question. And then you use the synonyms to do an exact match in your database with a keyword search. Or you could say you use, so if you would do it in a manual way, one could say, okay, I have a question about the data. I just use ChatGPT or another system to create a SPARQL query. So I go to my LLM and say, please create a SPARQL query that gets me the most famous person of the 17th century from Wikidata. And then maybe I get a SPARQL query that works or might not work. We can use such a component here to gather our Wiki-based data the same way. And then the last strategy would be, as we know already our own data model, the structure of our data model, we could say we already have some SPARQL queries that are able to get information out of our data. So for example, a SPARQL query that fetches persons out of our database. And we could say we use an LLM just to set some parameters in the SPARQL query. So to assuming we know that the user wants to get information about persons, but we just have to fill out the century he's searching for or the category of persons. So thus we are bringing in our context information, and the result is much better than when the user goes manually to a large language model and try to create a SPARQL query for a database he doesn't know anything about. Okay, so features of all the system is with Wikibase for Research, we have a one-click installation, bit of configuration after that, but it's easy to install. We have a lot of possibilities to provide models. So you can run the models locally. You can use models from Hugging Face. The GWDG service SAIA provides an API with models that run online. So that's also really cool. We have multi-language models that can be used here, structured, unstructured data, and even GPU usage. So the Llama framework brings a lot on board here. Our challenges are performance of model inference. So for us, it's good to have an online service like the SAIA service, where you don't have to run the models on your own computer. It's possible on notebooks, but it's a bit slow. And a challenge is, how do we configure the RAG strategies? You see that the system works best if we configure it well, but someone has to do it, and we need good ways to not overwhelm the user with configuration. And last, we research structured and unstructured data needs to be combined. Our outlook is that we want to provide it as a standalone component. So it can be used standalone, but it's not, we don't have a documentation for that. Maybe we will write an implementation to the Blaze Graph Store, which is a database beneath Wikibase, so to have direct access to the data. And our greatest wish is maybe we will work on an auto-rag system, which means that you provide your data and an example of 20, 30, or 40 questions together with the correct answers. And then the system will try different configurations to find out which is the best configuration for the RAG system to answer your example questions, so that you get help with the initialization and get out with the best system. Yeah, thank you very much. In my presentation here, you see the link to Wikibase for Research and to the RAG system. And the Open Science Lab also provides support in setting up all these systems. Thank you very much.
Thank you, Kolja. So again, I'm reminding the audience that if you have any questions to the speaker, please post them on the discussion in the chat and in the forum. And we do have some questions. So the first question is, if you have a SPARQL template with just a few blanks to fill, isn't using an LLM a bit silly? You could use a form instead, couldn't you?
Yeah, that's correct. If you have one form, or if you have just one SPARQL query, you don't need to use an LLM. But assume you have 10 templates. You have persons and cars and other things, and you don't want to have the form too complex, then it might be easier for the user to access the data in natural language.
Right. Okay, I have another question. So I saw in your examples that you had the data in German, and then at least on the slides, the questions and answers were in English. So that just sort of prompted the question: how does this work across languages? So if you have a question in one language, but the data is in another, or even a mixture of languages, does this still work? Or
it depends on the model. So there are models that are trained on corpora in a single language, but we used explicitly models for embedding that are trained on English and German data, so we can use it. And then it's possible that you say, okay, my data is in German, but I provide my questions in English, and then it depends on the training quality of the model. And also it depends on the domain of knowledge you are in. So it works for sure, obviously better for common knowledge than for very special knowledge.
Okay, thank you. Another question from the audience. If the RAG module becomes standalone, will it expose a stable API so that platforms like Arches or custom fast API services can plug in easily?
Yes, the Docker service is already providing an API, and our the whole integration with Wikibase is that we wrote a small Wikibase component that access this API to get to trigger actions or deliver questions to the RAG system and display it then in Wikibase.
Okay, thank you. Okay, another question from sort of the user perspective. If you you showed some examples of questions that were answered properly, but then one where the answer wasn't entirely correct. So how do you as a user know, or is there a way to check the answer of the system, for example, going into the original data sources?
Yeah, in our system, we implement it in a way that we say we provide the source that the system used. So there are three ways. You can provide just the answer, or you provide the answer together with the sources that were used, or maybe even better, you provide just the sources and say, okay, you might find your answer on page 3 in this article.
But if in your example case, the problem was that the RAG system didn't find the right piece of context to answer the question. So in that case, even if it showed the sources, it wouldn't have shown the sort of the right one.
Yeah, that's a general problem of maybe not only of LLM, but general of information retrieval. You get some information, it might be correct, but it might be not the best piece of information that's in the database. And I can think of no chance to find it. It's a bit of a round trip.
Yeah, I see the problem. Okay. Okay, one more question. So it seemed to me that you have quite a lot of components here in the system, like the different pieces that sort of are working together. So, and all of these are as I understand, sort of actively maintained projects. So how do you handle updates over time when all of these get new releases and they might have compatibility issues and security issues reported and things like this?
Yeah, we have in Wikibase for research, we have a extension management. So where we define via config files stable presets where we say, okay, we tested all these components together and we know the specific version that are working together and are free of the bugs. But if you want to have updates, you can also leave this open and say, okay, I want the latest version, but then it happens that a component updates and you get a dependency error and your system doesn't work again. So these are the pros and cons. But you can use these presets that we have to get a stable release there.
Okay, then this is probably the final question from the audience. So is this a sensible starting point to build a system if I have a large RDF graph I want to chat with?
If you are, so I would say if you are a user and if you are not familiar with any software, Wikibase for research is a good way to start as well as other systems. If you have already some experience with Wikibase, it's a great way to start because then you have a familiar tool that you now can use with LLM systems. Yeah.
Okay, there was one final question. So can you ask the user to rephrase the question so that better answers may be retrieved, or to give instructions that may help the user to get the best answer?
Yes. So for example, I saw that there are some strategies that are take the question of the user and use an LLM to create an even better question out of it to make your information retrieval better. So creativity is, you can use your creativity to come up with the best strategy, but that's then part of the, let's say, system administrator. What's the best strategy for my data to get the best out of it? And LlamaIndex provide a lot of components here to help.
Okay, thank you very much. This was a very exciting talk. So now now we are closing the session on queries and going into the coffee break. So you can take your pick of beverage, whatever you have locally. I have this 5-star linked data mug to sip my tea from. Unfortunately, it's a bit faded over the years. So let's go for a coffee break and return at past, so in around 15 minutes. Thanks.